Welcome to Scientific Exploration Network. Today we will have a journey with volcanoes. Remember November 23, 2025. It was a day etched into our memories, not for celebration, but for the raw power of nature. The highly Gubby volcano, in Ethiopia seemingly dormant giant, awoke with a thunderous roar, spewing ash high into the atmosphere. Flights were grounded, skies turned a bruised purple, and for a moment, the world held its breath. But what exactly causes such a magnificent and terrifying display? What lies beneath our feet that can unleash such fury? Today, we're going on a journey, deep into the Earth's fiery heart, to understand the science behind volcanoes. To truly grasp volcanoes, we need to understand our home planet. Imagine the Earth not as a solid ball, but as an onion with many layers. At its very core, a superheated solid inner core, surrounded by a liquid outer core. Then comes the mantle, a thick, semi-solid layer of rock, so hot it flows like extremely thick tar. And finally, our thin, fragile crust. We live on the thin outer skin of a giant globe almost 12,500 kilometers diameter. Beneath our feet, far beyond the ground we walk on, there's a raging world of molten liquid and roaring gases, burning at nearly 6,000 degrees Celsius, as hot as the surface of the sun. It's always moving, always alive. We call this place home, while a raging furnace hides below our feet. Fascinating, or terrifying? Now, let's zoom out to the grand cosmic ballet. Our solar system formed billions of years ago from a swirling cloud of gas and dust. As gravity pulled it together, our Earth began to differentiate, the heavier materials sinking to the center, and lighter materials forming the crust. This process, combined with the immense heat still trapped within, is what drives plate tectonics, the movement of massive pieces of the Earth's crust. It's at the boundaries of these plates where most volcanic activity occurs. Think of a volcano as a natural pressure relief valve for our planet. Deep beneath the surface, intense heat and pressure melt rock, creating something called magma. This magma, being less dense than the surrounding solid rock, begins to rise, collecting in magma chambers. As more magma accumulates, the pressure builds and builds, until it finds a weakness in the Earth's crust, a crack or a fault line, and blasts its way to the surface in a spectacular eruption. This is when magma becomes lava, and the show truly begins. But not all volcanoes are created equal. Some ooze lava gently like a leaky faucet, while others explode with the force of 1,000 atomic bombs. What makes them so different? It all comes down to a few key ingredients: the viscosity of their magma, the amount of gas trapped inside, and their fundamental chemical composition. Think of it like this: if you understand these factors, you can pretty much predict a volcano's personality. And the golden rule: high silica equals high viscosity, which means high gas retention, and that ultimately leads to an explosive eruption. Get ready, because we're about to break down the main types. First up, meet the shield volcano. These guys are the gentle giants of the volcanic world, typified by places like Mauna Loa in Hawaii. Why so chill? Because their magma is mafic, or basaltic. Think low silica, high iron and magnesium. This makes their lava super low viscosity, it's runny, like maple syrup or motor oil. It flows easily, spreading out for miles and building that iconic, broad, shield-like shape over time. And because the lava's so fluid, gases escape without much fuss. No dramatic pressure build-up here. Just beautiful, relatively quiet effusive eruptions that create those mesmerizing rivers of lava. Next, these are smaller, steeper, and often appear in clusters, like Paracutan in Mexico. Their magma is often similar in composition to shield volcanoes, mafic to intermediate, but with a critical difference. We have the spunky cinder cone. So, to recap the volcanic personalities: shield volcanoes, low silica, low viscosity, low gas, gentle, effusive, broad. Cinder cones, mafic, intermediate, high gas, energetic, fragments, steep, small cone. Composite volcanoes, high silica, high viscosity, high gas, explosive, deadly, tall, symmetrical. And sometimes, things get so explosive that the entire top of a volcano collapses, forming a massive crater called a caldera. Think Crater Lake in Oregon, a testament to the sheer power of these geological marvels. Throughout history, volcanoes have shaped our world, both literally and figuratively. Who can forget the devastating eruption of Mount Vesuvius in 79 AD, which buried the Roman cities of Pompeii and Herculaneum, preserving a snapshot of ancient life for eternity? Or the iconic, often snow-capped peak of Mount Fuji in Japan, a symbol of beauty and serenity, yet a powerful volcano in its own right. Then there's Krakatoa in 1883, whose eruption was so massive it caused tsunamis and global climate changes for years. These events remind us of the immense destructive power volcanoes possess. But it's not all doom and gloom. Volcanoes, while destructive, are also incredible architects of our planet. The ash and lava they deposit create incredibly fertile soil, perfect for agriculture. Many islands around the world, like Hawaii, are entirely formed by volcanic activity. They are also a source of geothermal energy, providing clean, sustainable power. And, believe it or not, some of the most precious minerals, including diamonds, are brought to the surface through volcanic pipes. So, while Haile Gubby was a stark reminder of their power, volcanoes are also essential for life on Earth. So, what can we do to mitigate the risks? While we can't stop a volcano from erupting, science is constantly improving our ability to predict and prepare. Scientists around the world use sophisticated equipment to monitor seismic activity, ground deformation, and gas emissions, all clues that a volcano might be stirring. Early warning systems, evacuation plans, and careful land use planning around active volcanoes are crucial for saving lives and minimizing damage. We learn from every eruption, constantly refining our understanding and response. As much as we advance in science and technology, there are some forces of nature that remain beyond our control. Volcanoes are a powerful testament to the living, breathing, ever-changing planet we inhabit. While we can study them, understand them, and even prepare for them, we must also acknowledge that sometimes, all we can do is stand in awe of their majesty and respect their immense power. The Earth will always continue its fiery dance, and we, as its inhabitants, must learn to dance with it. The quest for knowledge never ends. To keep your curiosity fueled with more scientific and educational insights, make sure to join our community at the Scientific Exploration Network. Hit that subscribe button for more such informative videos.